Okay, so in class we were talking about the angle addition postulate, and we take a look at the diagram here and notice that we have angle ABC going all the way across like this. And notice we have these two smaller angles, okay, both inside angle ABC, and they are an adjacent pair of angles. So according to the angle addition postulate, I could say the measure right here, okay, plus the measure right here equals the measure all the way across. So right here I could call that angle ABD. So I could say the measure of angle ABD plus this measure right here, the measure of angle DBC, equals the measure all the way across, and that would be the measure of angle ABC. Okay, and then we just have to substitute in and then solve the equation we have. And once we know what x is, I can find any missing angle measure I need. So let's see, the measure of angle ABD, that's x squared minus 9. Okay, so we get x squared minus 9 plus the measure of angle DBC, that's 5x plus 10, equals the measure of angle ABC. Well, it tells us right in the given information here that the measure of angle ABC is 85. Okay, so let's see, we would simplify the left-hand side by collecting similar terms, so I can add the negative 9 and the 10. So I'm going to get x squared plus 5x plus 1 equals 85. And notice that you have this term with x squared in it. Okay, so we have a quadratic, which means that we want to try to solve that by factoring. So to be able to solve it by factoring, we've got to put it in standard form. Okay, so I need everything on the same side. So I'm going to have to subtract 85 from both sides. So I get x squared plus 5x minus 1 minus 85 is negative 84 equals 0. Okay, so it's in standard form now, and we would want to try to factor that into a product of two binomials. So of course the x squared splits up into x and x, and notice that this last term, this constant term, is negative, so that means one of these has to be plus, one of them has to be minus, and then all I need are factors of negative 84 that add up to positive 5. Okay, and that would be a positive 12 and a negative 7. If I go 12 plus negative 7, I get 5, and if I go 12 times negative 7, I get negative 84. Okay, so we would get this x plus 12 equals 0, or we're going to get x minus 7 equals 0. Okay, and so this gives us x equals negative 12 as a solution, and this gives us x equals 7 as a solution. Okay, so let's see. I've got two possible solutions, so I have to check these. You know, does one of them work? Do both of them work? I don't know. Okay, so I've got to check. Okay, so let's check x equals 7 first. Okay, so when x equals 7, I've got to go back up here and evaluate. So we get the measure of angle ABD equals 7 squared minus 9. Okay, 7 squared is 49 minus 9, that would give me 40 degrees. Okay, let's check here. The measure of angle DBC, okay, would be 5 times 7 plus 10. Okay, so 5 times 7 is 35, plus 10 is 45. Okay, and notice that these two angles have to add up to 45, and they do. So we know that this works. Okay, this is a big yes. We know that x equals 7 gives us two angle measures, okay, that work out. Okay, so now we've got to try x equals -12. So I'll go to the measure of ABD first, measure of angle ABD. Well, that's right here, so that's going to give me -12 squared minus 9. -12, when I square it, I get 144 minus 9. So that will give me 135 degrees. Okay, now I have to do measure of angle DBC. And notice that's 5x plus 10, so I'd have to go 5 times 12. I'm sorry, -12. Let me erase that. 5 times -12, not +12. Plus 10. Okay, so let's see. 5 times -12 would give me a -60, plus 10 gives me -50 degrees. Now, we don't work with negative angle measures, okay? So this guy does not work out. Okay, so we only have one valid solution right here. Okay, x equals 7, and it gives us the two angle measures we're looking for. Okay, so notice it says find the measure of angle ABD and find the measure of angle ABC. Okay, well, we already know the measure of angle ABC. ABC is 85 degrees, so it gives us that one, so that's no big deal. Okay, and then it wants the measure of angle ABD. ABD, that's right here, and we found that to be 40 degrees. So we're in good shape, okay? All right, so this is gonna happen on a regular basis when you get a quadratic, okay? And we have to solve that using, factoring if possible. Okay, so just like you did in Algebra 1, so we get more than one possible solution, and we could end up with solutions that do work within the context of the problem, and we could end up with solutions that do not work within the context of the problem. That's why you have to go back and check them. Okay, let's see. This guy right here. Okay, similar type problem. So let's see, I've got this angle in here, okay, angle ABD, and I have this angle here and here, which I could call angle DBC. And notice, according to the angle addition postulate, that will give me the measure all the way across of angle ABD. I'm sorry, ABC, my fault. Okay, so I can say the measure of angle ABD plus the measure of angle DBC equals the measure all the way across here of angle ABC. Okay, so we're going to once again substitute in, substitute in, substitute in, and let's see what we get here. Okay, so the measure of angle ABD, ABD is 7x plus 1. Plus the measure of angle DBC, DBC, well that's 10x minus 22. Equals the measure of angle ABC going all the way across, and notice if we look up in our given information, it tells us that's 9x plus 9. Okay, so notice that I don't have any x squared, so we're not going to get a quadratic equation. So this is basically a very similar type equation you would have seen in 9th grade, 8th grade, and probably even in 7th grade. So we just simplify the left-hand side, so 7x plus 10x is 17x. 1 minus 22 would be negative 21, and then just bring down that 9x plus 9. Okay, so let's see what we got going on here. I want to collect these two terms, so I'm going to subtract 9x from both sides. Okay, so 17x minus 9x is 8x. And then here I would add 21 to both sides, so 21 plus 9 is 30. And then we divide. Okay, so I would get 8 equals 30 over 8, and obviously that doesn't divide evenly. Okay, so let's see, that would give me, it goes in there, let's see, what, 3 times with a remainder of 6, so I'd get 3 and 6/8, which is the same as 3 and divide both of them by 2 to reduce them, so I'd get 3/4. So it looks like I'm getting x equal to 3/4, and so we've got to check to make sure this works out. Okay, so I have got to evaluate here, here, and here and see if that works out. Okay, so let's see our check. Okay, let's take angle ABD. Okay, so the measure of angle ABD would be 7x plus 1, so it's 7 times 3 3/4 plus 1. Okay, so that's where this guy comes into play. Helpful, we can punch it in there. So 7 times 3 3/4, okay, and then add 1. So I get 27 1/4 degrees. 27 1/4 degrees. Okay, so let's work on this guy, angle DBC. Okay, so the measure of angle DBC. Okay, I have 10x minus 22, so I'd have to go 10 times 3 3/4 minus 22. Okay, so again, that's where this calculator becomes helpful. So 10 times 3 3/4, okay, minus 22. So I get 15.5 degrees. Okay, and now I have to check all the way across angle ABC. Okay, so the measure of angle ABC. Now we know that ABC is 9x plus 9. Okay, so I'm gonna have to go 9 times x, which is 3 3/4 plus 9. Okay, once again using the calculator, 9 times 3 3/4, enter, and then add 9 to it, and I'm going to get 42 3/4. So 42 3/4 pesos. So we have to ask ourselves, does this relationship work out? If I add these two, do I get this? So you check here, you say 27 1/4 plus 15 1/2. Does that equal 42 3/4? Okay, and let's see, 27 plus 15 is 42, and 1/4 plus 1/2 is 3/4. So notice it works out. Okay, so we should feel good about x being 3 3/4, and then let's see, it wants to know what's the measure of ABD and what's the measure of DBC. Okay, so your answer, okay, measure of angle ABD is 27 1/4 degrees, and the measure of angle DBC, let's see, DBC is 15.5 degrees. Okay, so there's your answer. Okay, so we're in good shape there. Okay, let's see what we got going on here. Okay, so we have an angle, and it measures 12 more than half its complement. Okay, so we're dealing with complements. So remember, okay, complementary angles, okay, remember that their, okay, angle measures add up to 90 degrees. So these two angle measures have to add up to 90 degrees. Okay, so let's see, we have an angle and we have its complement. Okay, so it tells us that an angle measures 12 more than half its complement. So we know something about the angle. It's 12 more than half of something. We know absolutely nothing about its complement. Okay, so let your unknown be what you know the least amount about, the complement. And so this angle would be 12 more than, that's 12 plus half its complement. That would be 1/2 times the complement. Okay, so we're going to get 1/2 times the complement, which is x, plus 12. And we know that these two, since they are complementary, they have to add up to 90 degrees. Okay, so if I go 1/2 x plus 12 plus the complement, which is just x, that has to be 90 degrees. And we solve this. Okay, so we add the left-hand side, and remember that'd be 1/2 x plus 1x. So 1/2 plus 1 is 1.5 or 3/2. Okay, so we get 3/2 x plus 12 equals 90. So subtract 12 from both sides, so we get 3/2 x equals 78. And then I have to take the 78 and divide by 3/2. So again, that's where this comes into play. So we go 78 divided by 3/2, and it gives us 52. So it looks like x is 52. All right, now it wants us to find the measure of both angles. Okay, so let's see our answer. Okay, let's see. Well, it doesn't matter. I've got to evaluate both of these. So you just, whichever order you want to do them in, it doesn't really make any difference. Okay, so if we take that angle, okay, and let's see, it's 1/2 x, and x is 52. So I go 1/2 52 plus 12. Okay, half of 52 is 26. So if I go 26 plus 12, I'm going to end up with, what, 38 pesos? Okay, and then if we look at the complement, well, the complement is just x, and x is 52. So we take a look at these. Now, if it's in good shape and things work out, I know that these two angle measures have to add up to 90 degrees because they're complements. So if we take a look at 38 degrees and 52 degrees, if we add those, we do get 90 degrees. So we're in good shape. Okay, so the two angles that we're working with, one of them has to be 38 degrees and one of them has to be 52 degrees. Okay, so we're good there. Okay, very similar type problem. Okay, we have an angle, and notice again we're working with complements, so the two angles that we have, the angle and its complement, have to add up to 90 degrees. Okay. Okay, so let's see. Well, we know something about the angle. It's 10 less than 3 times something. Okay, so I know something about this guy. I know absolutely nothing about the complement, so I'll let that be my unknown. Okay, so let's see. 10 less than 3 times its complement. So that would be 3 times the complement, 3x minus 10. Okay, so I have that is one of the angle measures, and this is the other one. And we know that both of these guys, okay, have to add up to 90 degrees. Okay, so I have 3x minus 10 plus the x. Those have to add up to 90 degrees. Okay, so simplifying the left-hand side, I get 4x minus 10 equals 90. Add 10 to both sides, so I get 4x equals 100. Okay, and dividing by 4, so x has to be 25. Okay, so we've got to check that and see if things work out. Okay, so let's come up with our two angle measures. Okay, so let's see. The angle up here is 3x minus 10, so that'd be 3 times 25. And then subtract 10. Okay, so let's see, that's going to give me 75 minus 10, so I get 65 degrees. Okay, and then the complement, Well, that's just x, and x is 25, so it looks like that's going to be 25 degrees. And again, notice that these two angles are complementary, so they have to add up to 90 degrees. So if you look, one of them measures 65 degrees, the other guy measures 25 degrees, and when you add those, you do get 90 degrees. So we're in good shape. Okay, so we have one angle is 65 degrees, one angle is 25 degrees, and we're in good shape. Okay, that'll end this video.